Hello, grade 9 mathematicians. It's Mr. Blathoven. We're doing a little video lesson on our new unit, which is polynomials, and we're starting to look more at algebra. And you might remember a real simple definition for algebra understanding. It is we're starting to use letters to represent some of our ideas and some of our numbers now. So we're going on into algebra. And we're starting with polynomials to help us understand the different terms. We've been using some different terms already, especially when we've been doing the exponent laws. And we've been using and applying the exponent laws for things like multiplication and division. But we haven't really been doing with addition or subtraction yet. So we need to know a little bit about what polynomials are. And maybe we need to know more about what nomials are. And you might know what poly is, but let's break it down. And if you speak in one tone, so if somebody is a speaker that, or a talker that just talks in one tone without any excitement, or they don't raise their voice, or they don't lower their voice, it's often just called monotone. Monotone. If you have been on some railroads in other places, we don't have too many here, I don't think, in Canada, but some of them you'll have monorails. I think if you've ever been to Disney or if you've ever been to some of these parks, they have trains and they just have one rail. That would be a monorail. So mono means one. So mono equals one. If you ride around on a method of transportation that has two wheels and a pedal, it would be called a bicycle. Bicycle, I spelled bicycle wrong. And bicycle has two wheels. So bi means two. So we think of the prefix bi, it means two. In my class the other day, a few of you were quite interested in the little number lesson I was giving on binary. So binary numbers. Binary numbers, and again, they used only the numbers 0 and 1, meaning there's only two numbers in the entire number system. It's just made up of ones and zeros. Well, other things, if you flex your biceps, there's two muscles in your biceps. So that's why it's called a bicep. On the back of your arm, where you have three muscles, or you have your tricep, there's three parts. When you run a race that has three parts, maybe some of you, I'd be curious if anybody's done one of these. Maybe you've done a triathlon. Triathlon, meaning three. Or maybe when you were little, you rode a tricycle. Or if you like to do photography, you use a tripod. It has three legs. So in the same way, we can have an expression. An expression is usually a combination of letters and numbers with a unique number of terms. They have to have a unique number of terms because that's very important. If they're the same, we can combine them, and we'll do that in a little bit. And we call this a monomial. I'm just going to scroll down a little bit. A monomial. Okay, and as you're watching this video, at any time you want, just kind of pause it if you need to think about it for a while or do some practice. Or if you want to review it and back it up and start over, or if you want to speed me up and you're like, oh, this is easy, I'm getting it, and I can listen faster than I can talk, then go ahead and speed it up. You've got all kinds of strategies to use there. An example of a monomial would be 3x squared. It has one term. So we're going to do a binomial, and you're probably already understanding that a binomial must have two terms. So 3x squared, and I'm going to add 4y. X's and y's are different. An x squared is different than a y, so they are two unique terms. If we do a trinomial, then we can example, we know it's going to have three unique terms, so here's our squared still, plus our 4y, And I'm going to add a 5xy. An xy, again, is different than an x squared, and it's different than a y. If we have many terms, we kind of stop counting after 3 and giving it its own name. If we have many, we have a polynomial. And maybe you remember back in elementary math when you were studying shapes, maybe you had talked about something called a polygon. And a polygon just had a side, it was just a shape with a bunch of different sides, not necessarily knowing how many. And our example for this, and again, it's going to have many terms, so we're going to go with 3x squared using the same example, 4y plus 5xy plus, we're just going to add a couple of other ones here, 2y squared, and y squared is different than a y, and we're going to add a plus 7. This plus 7 here, I just want to, let's name it right away, just so that we know. This is different. This is a constant, and this constant doesn't change. 7 doesn't change, right? 7 is always 7. But this could change, like this term here could change based on what the value of x is. We could change the value of x. So maybe you're kind of getting this and you want to pause and you're like, I get this, I'm going to try this one on my own, but I'm going to say try it on your own, come back or restart the video and figure out or try to identify these. Is it a monomial with one term, a binomial with 2 terms, or a trinomial with 3 terms? So I'm going to look here. Okay, I've got an x, and I've got this one here with a y. So it's got 2 different terms, so it is a binomial. And I want you to notice right away, I'm identifying or I'm underlining these different terms. So use a straight line here, use a squiggly line. So as mathematicians, good mathematicians, which we all are, we agree, good mathematicians agree to communicate well. And we'll talk more about communication down below too. This one, it's got a whole lot of letters in it, but it is just one term. It's negative 4xy squared z to the 7. It is a monomial because there's no plus sign holding any of those terms together. It's just one. On this one, let's identify them. We have an x, we have an xy, and we've got a y. And this one would be a trinomial. And this one, you might look at it and go, well, I've got 2 different terms. I've got addition, which we said it had to have. But we can actually combine these because these are like terms. It's kind of like saying I've got 5 Kit Kat bars and 8 Kit Kat bars. If I put them together, I've got 13 Kit Kat bars. So this ends up being a monomial because we can do something like this and just go, well, I've got 13a. This next part about descending powers, this is again, I'm going to go right back up to here with a different color. This one uses gray. This is again, good mathematicians agree to communicate well. So we're going to go descending powers of x means to arrange each term of the polynomial from the highest exponent of x to the lowest exponent of x. So we're going to look at this one, and we're going to write it in descending powers. So we're going to look at them and say, okay, what's the highest power? Let me pick this color. So my highest exponent, I've got an x to the 9. Here I've got an x to the 4. That's my second highest. Here's my third highest, and this is my last one. I'm going to write it as negative 2x to the 9. Then we said it was plus 8x x to the 4, and then plus 3x squared is our third one, and then we have this negative 4 just kicking around over here. Again, if you want to try these, you're going, hey, I kind of get this, I'm going to try it. Go ahead, try these on your own, and maybe just pause the video, fast forward it a little bit to see if you've got the same answer that I'm going to get. But I'm just going to take it nice and slow and get our steps here. So the first thing I want to do is I want to identify what is my highest number. This looks like my highest. It's x to the 6. Here I've got an x to the 4. Here I've got an x cubed. Here I've got just an x. And over here, my last one, I've got my constant. So I'm going to do plus 2x to the 6. Plus, we said my x4 is my next one. Then we said negative 3x cubed was our third. Plus 8x x, and then a plus 1. So we have that one done. And we can see that they are in descending order of exponents. So 6, 4, 3, 1, and no exponents. And that would be our, these again would be our constants. So here I'm going to again identify which one is my highest. That's my highest exponent, second highest exponent, third highest exponent, fourth highest exponent. So 5x to the 12 plus 10, nope, made a mistake. 5x to the 12 plus x to the 10. I did 10x. X to the 10, hopefully you can see that's a 0. And then we have our third one, which is negative x cubed minus x. And it looks like I have forgotten my constant, which is my fifth one, so I've got plus 8. Let me double check. Maybe double check that one for me to see if you got the same thing I did. But here they are in descending powers of x, meaning we're arranging them from the highest exponent of x to the lowest exponent of x. Later on this next sheet, we're going to have a question where we actually also have to do it not just in order of exponent, but also alphabetical. So we want our, yeah, I'll explain that when we get to that question. But again, moving up, this is what good mathematicians agree to do. We agree to communicate well. We're going to identify the terms that we have, and we're going to list them in descending order. On to the next page. We're whipping through this. And again, if you're stuck on a part, just pause it, maybe back it up, and maybe listen to the instruction again, or try some, or if you're stuck again, then talk to Miss Elsinga, because she's in all of our classes. So here we're looking at like terms. So we've got to know what a like term is. Let me change my color for us. We'll try that one. When the letter parts of the term, not a very good straight line, are exactly the same. That's an important piece. They need to be exactly the same. Then they are like terms. So we're going to look here, and each line below, we're going to circle the terms that are like the first term in the line. So here's our first one. So I've got a y, and I've got to circle all the ones that have just a y. Well, 3y is the same, right? The letter part is the same. Negative y is the same, so I'm going to circle that one. Negative y is the same. The y is the same. It's just the negative sign that's different. Xy, not the same. Y squared, not the same because it's not a y. This one, we have an x squared is our term. Nope, not a 3x. 5x, yep, we've got the same term. Right, so we've got the x squared, so we're going to circle that one. That's the only one in there because x cubed is not the same and x isn't the same. Here we've got a 3x. It is similar to 5x, right? Because the letter part is the exact same. Letter part not the exact same. So this has an exponent 3. This has an exponent 2. But this has the same one. So it is also a like term. This next question, just write a couple of different examples. I'll do 2 examples for us using what I think is the ugliest color in this color palette. So the letter part needs to be the same. Well, there's infinite number of terms that would have the same letter part. Like I could do 2x y cubed. I could do negative 37x y cubed. So you can do any number as long as this letter part is the same. And again, it has to have the same exponents too. Do we agree? Is this the ugliest color? Ugliest color. On the smartboard. Unless you like olives, maybe it's olive green or something like that. If you like olives, then you might like that color. We're going to look at these next ones. We're going to try to simplify these. Let me change that color though. And we're going to go with, we'll go with this color. So we're going to simplify each expression by, sorry, typo here. Funny that I used the word combing. We're going to, by combining like terms. And we know that like terms need to have the same letter part. And we're going to identify these. We're going to be really, really, really neat and tidy with our identifying, meticulous. So we're going to pay very close attention. So we're going to underline these because these have the same term. So 5x plus 7x, or if I had 5 O Henry bars plus 7 O Henry bars, I would have 12 O Henry bars, or in this case, I'd have 12 x's. If you are confident to go on with these, again, just pause the video and maybe check your answers. But maybe make sure, rather, that you identify the terms and organize your like terms. So this is a really important part. This is, again, the way we as mathematicians agree to communicate. Okay, so I'm going to look at this, and I'm going to do an extra step. So I've got y minus 3y plus 2 minus 7. So I've got y minus 3y, which is negative 2y, plus 2 minus 7, 2 minus 7. 2 minus 7 is a negative 5. And then this one here, again, I'm going to identify my terms. I've got a y squared. Here's a y squared. Here's a y. Here's a y. Here's a constant. Here's a constant. So I'm going to reorganize. Again, some of us might be ready to skip that reorganizing step. I just want to show you all the steps for this piece here. Plus 2y plus a y plus a 4 minus a 1. So let's look here. I've got 3 y's, and again, there's the invisible number in front of a letter, right? If there's nothing there. So I've got 4y squareds plus, I got 3 y's, and I have 3. Hopefully you're getting the same answer I am, or hopefully I'm getting the same answer you are. We're going to identify what we have here. We've got x squareds, we have an x, we have a constant, we have a constant. Let me make that a little bit bigger. So I'm just going to write it out, extra step, x squared minus x squared plus 3x. And notice I'm doing this, I'm trying to do this already in descending order, like we talked about earlier. Plus, oops, plus 2 plus 1. X squared minus x squared would be 0. Plus 3x plus 3. And I'm just going to have 3x plus 3. Check that. Hopefully I got it right. And this one, Ryan in my class would love this question, because you just have to look at it and go, oh, there's nothing similar here. There are no like terms. I'm just going to write the question out again. If you want to ask Ryan why he's so good at that, you should ask him about the quiz that we did. This one, we're going to identify things. I've got a y squared. Here I've got a y. Here I've got a y, even though it's a negative 15y. I've got an 8y. I've got x, and I've got an x. Well, let's try to organize these. We're going to go highest to lowest. So I'm going to have negative 9y squared. And then I got to think about which one I want to do next. They both have an exponent of 1, right? Because we know that x is really x to the exponent 1. They both have an exponent 1, but I've got x's and y's left. I actually want to do them alphabetically. So now I want to do my x's. So I'm going to have my plus 7x minus 9x plus y. That should be a minus. Let me change that. That's a terrible y. So this is going to be a plus y minus 15y and plus 8y. Let's see how I do here. So I've got minus 9 y squared minus 2x, so 7x minus 9x is minus 2x. And here I've got a plus 1, so y minus 15y, that would be minus 14y plus 8. Negative 14 plus 8 would be a negative 6y. And there's my answer for that one. And now let's go to this very last one here. And this one is a bit tricky. I'm just in a different color so you can see where it's a bit different than our other ones. I don't think I've used an orange yet. Maybe I have. I'm going to identify my like terms. I've got AB cubed. Here's another AB cubed. Here's another AB cubed. Here I've got an AB, and I might look, do I have another AB? And I'm like, well, we tried to trick you. This is actually the same thing because A times B is the same as B times A for the most part. And in this case, it works. They're just out of order, actually. Somebody didn't communicate very well in this one. And I've got my constant here. So let's go write these out. We're going to equals 23 AB cubed minus AB cubed minus 9 AB cubed plus AB. That should be a minus. Minus 4. I'm going to rearrange this now because I want to communicate better. And a minus 12. So let's start to do this. So 23 AB minus 1 AB would be 22. 22 minus 9 is 13 AB cubed. Minus, so here now I'm over here, minus 3 AB and minus 12. So there you go. There's our note for polynomials. Just a couple of things I just want to go over before I leave you. Polynomials. So we looked at the different polynomials. We've got monomials, binomials, and trinomials. The polynomials, if we don't know how many terms there are if it's more than 3. We identified what these were. We talked about writing them in descending power of x's. So this is where we as good mathematicians, right? This is really important. Good mathematicians agree to communicate well. So we're going to write them in descending order. Go to our next page. We looked at what like terms are. And we started to identify and use like little ways to note the different terms by combining the like terms. We looked at perhaps the ugliest color on the smartboard. Group, that's it. Thanks for this. Again, if you need to pause it, rewind it, review it. We will have some practice for these on Monday. Have a good weekend, everybody.